Hello, mathematicians. Today we're going to be graphing in slope-intercept form, and we're going to be using positive slopes in this video. So here I have an equation in slope-intercept form, and it's y equals 2x plus 4. And before we begin graphing, let's talk about the different parts that we have here. So our y and our x variable represent any coordinate on this line. Our 2 represents our slope, and our 4 here represents our y-intercept. So remember that our y-intercept is when our line intercepts the y-axis. So if I look at my y-axis here, since it intercepts at 4, we're going to plot a coordinate over here. And our y-intercept is always when x equals 0. So in this coordinate here, it's 0, 4. And our slope is a rate of change. So every time, so our slope here is 2. So every time we rise 2, we're going to run 1. And what that means is starting at this coordinate here, we're going to go up 2 units and over 1. And then up 2 units and over 1. Because our slope represents a rate of change, so if we do have a whole number here, and if you want to write it as a fraction, the best case is to write it over 1. Or if you just know that it's 2 over 1, that's perfectly fine. And rise over run represents our slope. So here I have 3 coordinates. That's more than enough to draw a line. And remember to draw arrows at the end of our line to show that it continues unless our function is restricted. So here I have another equation in slope-intercept form. It's y equals 4x minus 5. And again, in front of our x, we have our slope here. That's also represented by the variable m if we don't know it. And here we have our y-intercept, which is negative 5. And the reason why it's negative 5 is because here I have 4x minus 5, okay? So don't forget that. And the easiest thing to do is to plot our y-intercept first. So our y-intercept is where it crosses here on this line, and it crosses at negative 5. So I'm going to plot a coordinate here on negative 5, and our y-intercept is always when x equals 0. So here our slope is 4. Remember, it's much easier if we write it as a fraction, so 4 over 1. And we know that 4 is our rise and 1 is our run. Meaning, from this coordinate, I'm going to go up 4 units, 1, 2, 3, 4, and I'm going to go to the right 1. And the reason why I go up 4 is because our slope is positive, and the reason why I go to the right 1 is because our 1 here is also positive. And I'm going to plot another coordinate. So 1, 2, 3, 4, and then over 1. And I have 3 coordinates. That's more than enough. You actually only need 2. So I'm going to take these and I'm going to connect them. I'm going to try to do it as straight as I can. And remember to draw our arrows at the end of our line to show that our line continues. Here I have another equation in slope-intercept form. It's y equals 1/3 x minus 5. And it's the same thing, except here our slope is a fraction already. So this is our slope. And negative 5 is our y-intercept. And the easiest thing to do is to plot our y-intercept. So our line crosses our coordinate at y-axis at negative 5. So I'm going to put a coordinate here, a negative 5. And our slope is 1 over 3. And remember, 1 is our rise, and 3 is our run. So from this coordinate, I'm going to go up 1 because our numerator is 1 and that's our rise. And then I'm going to go to the right 3 because both 1 and 3 are positive. So the positive 1 tells us that we go up, and the positive 3 tells us we go to the right 3. And then we could plot another one, or even a second and a third coordinate if we wanted to. And here I have 3 coordinates, which is more than enough, and all I have to do is connect them. And draw an arrow at the end to show that this keeps going. And finally, here I have y equals 3 over 4x plus 1. Remember that the 3/4 is our slope. Our 1 is our y-intercept. And so here, our line intercepts our y-axis at positive 1. And our slope here is 3 over 4. So our rise over run. And from this coordinate, we're going to go up 3 because the 3 is positive. So 1, 2, 3. And then we're going to go to the right 4 because the 4 is positive. So 1, 2, 3, 4. So remember up 3, so 1, 2, 3, and then to the right 4, 1, 2, 3, 4. And that's it. And so I'm going to draw my line through these coordinates. And then draw an arrow at the end to show that our line continues. So unless our function is restricted, we do draw an arrow at each end. And that's it. That's how we graph in slope-intercept form and with our positive slope.